In this video, we will begin our discussion of section 11.2. This is space coordinates of vectors in space. So what they mean by space is not outer space. They mean three-dimensional space, the space we live in. Before extending this concept of vector to three dimensions, okay, so you must be able to identify the points of a three-dimensional coordinate system. So where we're headed is a three dimensions. That's the whole point of Calc 3 is we're going to take everything you learned in Calc 1 and 2 and figure out how does it actually apply in three dimensions. So let's take a look at the graph over there. Notice that the flat plane, xy plane, is our normal graph. And then we have z coming up and z going down. So it adds a third dimension, giving us three space. So x, y, and z. A couple definitions for this. This is called the coordinate plane. Each one has xy plane, xz plane, yz plane. You can see each one here in this picture. We are going to be talking about planes quite a bit, so please make sure you know what I mean. When I say yz plane, I mean like taking the x-axis out and only looking at this panel here, like flat. So how we actually, in two dimensionals, we had quadrants, right? 4. In three space, we have something called octants. Octants being the same thing, but now we have three spaces. So imagine, we have 4 spaces up on this side. It's hard for me to show you in 3 dimensions. But if you look here, there are 8 different rooms in that picture. First floor and second floor. So those are our octants. How we make a point in 3 space is instead of giving 2 points, an x and a y, we give 3, an x, y, and a z. So let's take a look over here. Take a look at this point right here, 1, 6, 0. So notice in the x direction, that's our first one, it went 1. And then the y direction, it went 6. And then the z direction, it went 0. So that's why the point is down there on the ground. Now looking at this point, sorry about that. This point here, we have -2 in the x direction. We have 5 in the y direction, and then it says go 4 up. So it's just like xy, but now we just have a third one going up and down in 3 space. Right? There are 2 different ways to think about this system, three-dimensional system, I mean. We can look at a right-handed system, or we can look at a left-handed system. A right-handed system is your right hand is the x-axis. So it'd be like the pillar of this dude is the z-axis, and then x is the one coming out at us, and y is the one going off to the side. There is also a left-handed system where x is the left hand. We're not going to use that at all. It's not standard to use it. There may be a couple curriculums, but for the most part, all books typically use this right-handed system here. I'm going to go ahead and give you the distance formula. It is the Pythagorean theorem. You can go ahead and read through this, and I would suggest you think about why this works. But the extension from 2 dimensions distance formula to 3 dimensions, you just add the z component. That's it. So remember, distance formula is subtract our x's, subtract our y, square them, add them together, take the square root. You just add the z one in there now. So let's look at an example here. It says find the distance between the points. Right, so distance equals, and I subtract each one, so 1 minus 3 squared plus 0 minus -4 squared plus -4 minus 7 squared, and you just work it out. So we get, inside we get 4 after I subtract and square, plus 16 plus 121. That is the square root of 141. You can leave it there. That's perfect. Unless they ask for an approximation. Right? So there is my distance between those 2 points in 3 space. A sphere. Okay, so one thing and you guys probably have it down at this point, in Calc 1 and 2, they really focus on the circle a lot. So it would be natural for us to extend, if we're going to keep working in 3 space and start working towards that, to consider a sphere and get used to working with a sphere. Now, remember a circle. Okay, take a look at our box down here. Here's the definition of a sphere. If I cover this up, our third dimension, z, that is the equation of a circle. So adding in that third dimension makes it a sphere. All right, the same thing with our midpoint formula. If I cover up the z one, that is for 2 space, right, between 2 points in 2 dimensions. To get it in 3 dimensions, we just add our z component. That's it. I'm not going to derive those again because they're very similar to the ones that you guys should have done in algebra. If you're curious, I can send you to the right space. You just have to let me know. Right, one last example for this video. Example 2, the standard equation of the sphere that has that. They want us to find the equation of the sphere that goes through those 2 points, but that's a diameter, endpoints, so straight across. So I'm going to find the distance of that, because if I look at the formula up here, I need an r. All right, so if the r is a radius, so I'm going to find the diameter first, which is the distance between these 2 points. So we get 0 minus 5 squared plus 4, and then if I do the subtraction correct, I'm going to start doing that, and then negative 3 minus 3 squared. This works out to be the square root of 142. Now, that's diameter. To find the radius is half of the diameter. So it's just going to be 1/2 square root of 142. That's a great answer. Okay, now, looking back at our equation of the sphere, we have r. Now we need an x naught, a y naught, and a z naught, and they told us that is the center of the sphere, right? Centered at here. Oops. Right there. So I need the center of the sphere. Well, the center of the sphere, if these are 2 endpoints on my sphere, right, like here and here, the center is the midpoint of those 2 points. So all I have to do is find the midpoint. So center, I average my x's, so 0 plus 5 over 2, negative 2 plus 4 over 2, and 3 plus negative 3 over 2. All right, so that means the center is 5 over 2, 1, 0. So now I just plug everything into my formula, and I am done. So it's x minus 5 over 2 squared plus y minus 1 squared plus z squared, because it's 0. And this equals 1/2 square root of 142 squared. If you want to, that is the same thing as 71 over 2. Either way is the correct answer for me. All I care about is the new things. The square is not new. That's arithmetic. So there we go. So it's not crazy. You just got to get used to this way of thinking in 3 dimensions that you've been so used to doing 2 dimensions for so long. Once you get to the graphing, you're really not going to like that. But really, the calculus in 3 dimensions isn't horrible. So we'll get there. We're working our way through that. We are going to spend the rest of this section discussing more 3-dimensional topics.